Hello, folks. Good morning, good afternoon, wherever you might be coming in from. Thanks so much for joining us. We're really looking forward to this webinar. I can still see folks are really trickling in right now. So we're going to give it, another 20 or 30 seconds or so before we go through a few housekeeping things and then kick off into the content. But thank you all for joining. We've got some great content to go through today. It's a nice real world use case. All right. So still see a few folks trickling in, but just to go through a few kind of basic housekeeping items first. First off, welcome. And you'll see we're in the platform called Demio. And the way Demio works, if you see on the right side of your screen, there's a chat. And that chat we have defaulted to public so that you guys can put questions in there, interact with each other if you'd like. Keep a good dialogue going. Anything that comes up on your mind, feel free to share. So right now you can see, fire away kind of where you're dialing in from. Hey, welcome from Rome, Colorado Springs, love it, welcome. Boise, I'm from Idaho, right on. So yeah, welcome folks. Also, you'll see there are a handful of polls kind of right next to the chat. So we have a few questions in there kind of about how you use LLMs or some of your bigger challenges. That just really helps us kind of guide what we do with this content in the future also. So make sure that, we're trying to answer the biggest questions for folks. And yeah, so go ahead and please take a moment to, fill out those poll responses. And also you'll see there's a couple other pieces of content that we're going to hand out. You can see there's the slide deck and a little bit of, a document just about Predibase. And with that, I think we are just going to go ahead and dive in. So Alex, if you could please advance to slide one. So yeah, a couple other logistics here. All your lines are muted. I forgot to mention that one. Like I said, there are the questions there. Also, what we're going to be doing today is we're going to have a notebook that we're going to share. And everything you see today, you're going to be able to kind of reproduce on your own if you'd like. So Predibase, we offer a free trial. You're welcome to go ahead and sign up. There's either that link you can see there, or just finding it from predibase.com. You'll see links to the free trial. It's a 30-day free trial and comes with $25 of credit. And that lets you, fine tune and serve LLMs, open source LLMs, all the way up to, 70 billion parameter LLMs. So go ahead, you can really kick the tires, follow along with this, watch the recording. We'll have it posted on YouTube in just a couple of days, so you can really get your hands dirty with it if you'd like. Alex, next slide, please. Wonderful. So we're going to start off by kind of covering some of those big issues in customer support. Maybe some of you are joining with customer support backgrounds, but it might be kind of new to you, to some others. So we're going to set a little bit of groundwork first. Before kind of providing an overview of conversation analysis using fine-tuned LLMs. We'll go through how we prepared the data set, give you an intro to Predibase, and then really open up that notebook and do a hands-on tutorial. Next slide, please, Alex. All right, and we are joined by Alex, who leads our developer relations. He's a DevRel engineer. And then also Maggie, one of our senior ML engineers. And they are really experts in what they do. So I'm excited to be opening up to them. Alex, next, please. All right, over to you, Alex. Thank you.
Thank you, Will. Hello, I'm Alex, and I would like to begin with the observation that in the field of customer support, caller to agent interactions, is important for tracking and improving the quality of customer service. Why? Because capturing relevant information from support call logs allows organizations to pinpoint recurrent problems in support conversations. These insights are then used to improve content and user experience, and this leads to greater customer satisfaction. It also results in more self-service, which is significant because on average, a single customer support call costs between $7 and $41. So if you multiply this by thousands of calls per week, this expense can quickly skyrocket. So naturally, a big incentive in leveraging this data because customer support departments are always cutting costs and streamlining their operations. Support agents, of course, play the key role in terms of customer satisfaction, which impacts call center efficiency. They are required to follow professional conversational etiquette and have proper qualifications and expertise. Recognizing this and measuring the agent's performance enables management to take actions, the kind of actions that would hopefully improve the support department's quality assurance program. For example, provide guidance and training to the agents proactively. And product feedback, when gleaned from customer support transcripts and shared with other department stakeholders. It can help shape the business priorities, inform decisions, and generally help to maintain the company's relevance in the marketplace. So we can say with certainty that absolutely capturing and analyzing support call logs is imperative. By the way, this webinar is being recorded for quality and training purposes. Sorry, couldn't resist that one. But actually, this is exactly why conversations are recorded and saved. For instance, in our upcoming demonstration, we will be working with voice calls that were recorded and transcribed into text. And these transcripts are saved. In the case of text messaging or chat, conversations are formatted as transcripts are saved. Regarding quality assurance, QA, the analysts look for certain salient indicators in the call logs. For example, what caused the customer to contact support in the first place? This is tagged in the transcript as contact driver. It is also known as task type. These tags are very important because they capture the intent, whether it's troubleshooting technical issues, seeking product information, resolving billing problems, shipping errors, whatever the case may be. Task types encapsulate the customer needs that compel the customer to pick up the phone and call support, or to click the button to chat with a representative. So our code walkthrough today will use the task illustration purposes because it is probably the most impactful of all attributes. The other key attribute is conversation marker. Conversation markers are just a way to highlight typical parts of a conversation. They tend to be fairly general across industries. For example, the greetings, the pleasantries, the issue reporting, or when things take a bad turn, no pun intended, such as, please get me the supervisor. Could you please transfer me to your supervisor? Sentiment, that is, of course, also very important. It directly relates to customer satisfaction. In the best scenarios, might even motivate customers to go on social media and shout out praises. So now that we have and a sense of what we're looking for, let's talk about the how, the mechanisms for achieving these objectives. The process of annotating the caller agent transcripts belongs to the broader discipline called conversation analysis. It involves a number of tasks, including transcribing the calls, reading them, and looking for patterns, analyzing them and marking them up, identifying contact drivers, tagging conversations with conversation markers, tracking customer sentiment throughout the conversation, and predicting the customer satisfaction score, the CSAT score. Needless to say, doing any of this manually is really asking for trouble, only leads to errors and confusion. Fortunately, today we have an approach that is a perfect fit for language-heavy tasks like customer support. The technology is large language models. And many of you are probably already using GPT 3.5 or GPT-4, most likely through OpenAI, to summarize transcripts and perhaps accomplish some other of these tasks as well. And OpenAI is great to start with. It's really easy to use. You don't need data science skills, just an English language prompt, and you're doing AI. The performance, in particular with GPT-4, seems quite good. So why not just keep using OpenAI for everything? Proof of concept, prototyping, development, production. Well, the truth of the matter is actually relying on OpenAI as part of a real commercial grade application in production environment is problematic because you don't own the model intellectual property and you never will. It's expensive at scale. And GPT, generative pre-trained transformer, the architecture being operated as a cloud service can be slow, rate limited, or simply unavailable due to outages, which you cannot do anything about. Not only is OpenAI an overkill and a massive overspend, and you don't control the quality of output on any given day, crucially, for a customer support application, what is needed is not a general purpose model, but the ability to engineer specific modules for the conversation analysis type of tasks, what we're discussing today, tagging, assigning conversation markers, performing sentiment analysis, and being confident that these modules will reliably produce highly accurate results, that they're safe and secure, that their output can be trusted, that they can be operated in a scalable way and do so cost effectively. So our recommended approach is LLM fine-tuning. Here's how fine-tuning works at a very high level. Large language models are good generalists, but they have little specialization. They're trained on many different tasks, so they know a bit about everything, kind of like jacks of all trades, but not enough about anything specific. Nevertheless, it turns out that by including additional weight matrices parameters, neural network architecture, we can also train them to solve a particular task very well, that particular task and nothing else. We call this customization process fine-tuning. We start with everything the model knows and adjust its knowledge to help it improve on the one particular task we care about. So to go over this one more time, essentially, the reason we want to fine-tune the base model is that base models are pre-trained on gigantic data sets, which makes them very general and not able to perform well on specialized tasks, like in our case, analyzing customer support transcripts. But fine-tuning does accomplish this. In addition, a big advantage of the fine-tuning The custom domain-specific datasets do not need to be large. Typically, small, high-quality datasets with 1,000 to 10,000 samples are sufficient to get a good fine-tuned model performance. And as we can see from this graph, in most cases, fine-tuning a much smaller general open source LLM on a domain-specific dataset outperforms the proprietary commercial models on these given tasks. A clarification is in order. It may be a subtle nuance. When we say that fine-tuned models are small, we are referring to the fact that we apply special techniques in the category called parameter efficient fine-tuning, or PEFT for short, and also quantization of the numeric model weights. It's data compression. A lot of recent breakthroughs in machine learning engineering has led to the reduction of memory footprint of the model's weight matrices. What it means concretely is that the open source 7 billion, 13 billion, and even 70 billion parameter models are significantly smaller than GPT 3.5 and GPT 4. As a result, the fine-tuning process incurs a dramatically lower cost to customize the open source model. And the performance efficacy is comparable to OpenAI and other closed commercial models. And this is extremely important. Generating predictions from the fine-tuned model comes at a fraction of the cost. Predictions is the predominant cost factor in production. So one benefit of fine-tuning is that thanks to the various optimization techniques, it can provide the state-of-the-art accuracy very cost effectively. Another benefit of fine-tuning is lower inference latency. Smaller models execute faster because with fewer parameters, the number of multiplications and additions needed to compute the output is also correspondingly lower. Switching gears now to our demo. Our objective is to discern the task type from voice call transcripts. As the base model, we will use the open source LLM called Zephyr-7 billion parameters. We picked Zephyr, best performing open source models of its size, and it has been known empirically to be easy to fine-tune using small data sets. And so the data set that we will use for fine-tuning is called Grid Space Stanford Harper Valley. It contains almost 1,500 customer support transcripts of voice conversations between callers and agents with rich annotations that include task type. Diving deeper into the exploratory data analysis part of our workflow, the transcripts in our example dataset are JSON files consisting of records. Each record or turn contains what was said and by whom, caller or agent, caller, agent, caller, agent, and also of noise on the line because these are transcriptions of voice calls. The metadata JSON files cover entire conversations rather than turn by turn like transcripts. So transcripts is turn by turn. Metadata, entire conversation. All turns, entire transcript. The task type is one of the key pieces of information contained in the metadata files. Now, a support call could contain several task types. There could be multiple reasons for contacting support, but here today for our illustration, so we can focus on fine-tuning. We will make a simplifying assumption that every conversation has exactly one task type. So then to put the data set together from each file in the transcripts directory, turns into a conversation by taking the speaker role field, caller or agent, and the human transcript field, transcribed plain text from each turn, and then we concatenate these parts together into a chat transcript. So that's our input. The output is task type. Data is then put into a pandas data frame, and this will be our data set that we will use for model fine-tuning. Here it is. This is our data set uploaded to Predibase. A few rows are displayed as an illustration where we also highlighted parts of the conversation to show how they may be influencing the corresponding task type tag, which is our label. Next, let me turn the presentation over to Magdi, who will provide more details about the Predibase cloud service and continue with our fine-tuning code walkthrough. Here is Magdi.
Hi, everyone. It's great to be here and to be chatting with you all. And I'm excited to show you how we can take what Alex just presented and walk through it in the Predibase platform. So let me just jump in. So basically, one important thing to note about Predibase as a platform is that what we provide is an ML framework as a service setup. This allows you to have maximum configurability, convenience, and efficiency when thinking through things like fine-tuning LLMs. The reason this is so effective is that Predibase provides a hosted, low-code, and declarative ML platform that makes things like fine-tuning very quick, and you don't need to worry about compute or setting up your own infrastructure because you only pay for what you use. Furthermore, we've provided optimized multi-GPU, both training and serving, so your time and resources are only spent on value-generating activities. I think it's time that we jump into like a code walkthrough. So the link here takes you to the demo version of this notebook, but this is a notebook that we actually ran to fine-tune the model. So as you can see here, we just start by downloading the Predibase SDK. And then you instantiate a version of the Predibase SDK using this Predibase client. One thing to note is that this is an API token generated for this demo, but if you sign up for a Predibase free trial, you can generate your own token here. And there are instructions on how you can do this in the other version of the notebook that we've shared with you all. So jumping in, the first thing that you can do is just see which LLM deployments are available to you now. So I've listed here a bunch of LLM deployments. These are all available to this account that I'm in. One thing worth noting is that we have this is shared flag. What this means is that you have two types of LLMs on the platform. You have LLMs that are shared. That means that you only pay for the tokens that you use, or you have dedicated deployments where this flag is false. And these are deployments that you set up in your own account, and then you pay for uptime. So we're going to be using this Zephyr-7B beta model, and this is a shared LLM. So let's walk you through how you go through something like that. So right now I'm importing this LLM deployment object and grabbing the deployment name that I care about, and I'm instantiating this base LLM deployment with the URI being this PD deployment name, which is Zephyr-7B beta. I can run it, grab it. I can make sure that the model is ready. So I wait, it says it's ready. And then I want to go ahead and try running a prompt against this model to check that given a transcript from what Alex told us about in this data set that includes transcripts and task types, given a transcript and this list of tasks, can we predict which task is the most relevant given this transcript? And we feed in this transcript here. So we basically create this config. We look at the config. We'll be using this later. But here we grab a transcript. We put the transcript into our prompt template, which is what I just showed you right here. This is the prompt template, takes in a transcript in here. And if we print it out, we see here's the compiled test prompt. It tells you to, like, gives you an overview of what we're going to try to do, gives you the transcript, and says, hey, what is this task type? So I can go ahead and prompt the LLM directly, and this is doing it live right now. And then I can just print the result. So as we can see, is that based on this task prompt and auto-completing what we're asking for, we get the following result. We say, like, okay, based on this conversation, the customer's reason for contacting customer support is that the answer is, like, they want to replace their debit card, the task type is replace card, and here's a summary. This is all great, but we really just wanted the words replace card. And this is something that we're going to focus on during fine-tuning, is can we just get the model to output the thing that we want? Clearly, it has the capacity to do the reasoning that we need, but we don't need all this extra text because we might want to plug this into some bigger system down the line. So continuing, we'll just show you how you can go ahead and fine-tune this pre-trained Zephyr LLM. I've hidden the pre-processing of the dataset steps, but you can take a look here. What you need to do here is just download the dataset and then connect it to the Colab notebook, and then the logic for generating the dataset is all in there. The important thing to note, though, is what you will get from running all of this is this data frame, which we call here a data frame dataset, which is just a pandas data frame that includes the dataset that Alex walked you through. And so the way we're going to go about this is we are going to go ahead and get started by first creating a dataset within Predibase. And so if I go into the Predibase platform, having run this, and I take a look, I can see that there's this GridSpace Stanford Harper Valley dataset that's been created with this preview that Alex showed. And if we take a look at the notebook, this is the dataset that we created on a previous run, but it's in there. And then we can go ahead and grab the LLM again. We can import this model future type. And then the thing that we need to do now is just go ahead and run fine-tune. And we can just do a quick walkthrough of what that entails. So we're passing in the prompt template. This is the same prompt template that we looked at before, which is saying, like, hey, I want for this prompt, I want to use this, and then with this target type transcript. So we're passing in the prompt template. We're passing in the target, and the target is the transcript, which is in that prompt template, the data set that we just created. And then we're saying, hey, we just want to train for 5 epochs. There are some few other optional parameters that we don't need to worry about right now, but then all we have to do is just hit fine-tune, and then it will create this model repository. And then if we just click on this link, it takes us to the model repo that we care about, which we've gone ahead and already trained ahead of time. One thing to note is we can see the total duration was 41 minutes, of which 32 minutes were spent training, 9 minutes were spent waiting on getting the valid compute to be up and running. And we see some significant improvement in this. This is the loss curve for our test set. And we see sort of the shape that we'd want to see for a loss curve, which is something sort of going down and hopefully plateauing. Maybe we could have gone for a bit longer here based on this. Great. So now that, and what you can see in this SDK is that, hey, you get all these metrics, and you get an idea of how long it's taking to go ahead and do this, and a breakdown by epoch. But now that we've done the fine tuning, let's go ahead and actually play around with this model. So, and this is stuff we're gonna run right now. So I'm going to run this to get the base LLM deployment again. I'm going to say, hey, my model name is this, which is the same that you can grab from this model repo. We can run that. We can say, hey, I want to get this model. I want to check that I have the correct version. The model version is version 1, which is what we're looking at. And then I actually want to go ahead and query the deployment. What we're going to do here is actually pretty cool. We're not going to do anything different. We already have Zephyr running as this shared deployment. All we're going to say is, hey, for this next query, please use it with the adapter that we trained while passing in the model name. What does this mean? It means that we can actually prompt many different fine-tune models against the same base deployment. So you can have fine-tuned 10, 20, 50 different adapters, and then for the same base deployment, you can keep querying with various adapters and get that fine-tuned behavior. So we can get the adapter deployment, we can just print the test prompt that we had used before, and then we can go ahead and just like prompt this adapter deployment, and we get it back. And now, if we run it, we see that the generated text is just replace card. It has actually dealt with this formatting issue that we were having before to allow us to just get the thing that we care about. And this is all that I wanted to show on the SDK side. So I'm just going to hop back into the presentation for a few quick things that I'd like to point out. So taking a step back and thinking about this, we see that actually productionizing LLMs without using a platform like this can be pretty tricky, because you have to worry about the complex training. You need to make sure that you have available GPUs. You need to make sure that you are setting up your training loop correctly, and dealing with things like out-of-memory errors. And model serving is quite costly, but you can circumvent that by using something like a shared deployment, where you like a fine-tuned shared deployment, where you're only paying for the tokens generated against something that's quite personal, like a model that you fine-tuned. And the last thing is, there are so many developments in the space that are happening on a weekly cadence, and it would be really a big burden to have to keep up with all of this yourself, as opposed to using a framework that already has this stuff baked in. One last thing that I want to point out about Predibase is that it is built on popular open source libraries that a lot of you may have heard before and used. So in this demo that we saw right now, we used the Ludwig framework to fine-tune the LLM. And then we used Lorax, which is a Predibase authored open source library that allows you to serve multiple fine-tuned adapters against one single GPU, which allows many of our customers to use their own adapters against one single shared deployment. That is quite cost effective for them, as they're only paying on tokens used. And then I would like at this point to hand it back to Alex to go over a summary of what we saw.
Thank you, Magdi. So we started by identifying the prerogatives for customer support departments, and mentioned that the technique for dealing with a lot of the challenges of transcribed calls is to employ the conversation analysis technique. Argued that LLMs are a natural fit, because it is a language to language applications, language technologies for a language problem. So LLMs are a natural fit for implementing the elements of conversation analysis. And it's totally all right, encouraged to use proprietary cloud services like OpenAI to get started, try a few things, proof of concept kind of experiments. But for the long-term production, fine-tuning an open source LLM is the best in terms of cost of ownership and performance cost effectiveness. So we introduced the Predibase platform as arguably the most cost-hosted service for fine-tuning LLMs with domain-specific data sets, and pointed out that with the latest part of the demo by Magdi, where you can have multiple adapters, you can serve them at scale for commercial-grade business applications like today's topic, customer support. So what that means in particular is you can train different customizations, different fine-tuned adapters for contact drivers, conversation markers, sentiment, and deploy them all at scale on one GPU. So thank you for joining us. We'll be delighted to take questions.
Wonderful. Thank you both so much for walking through that. I love that use case study, and hopefully folks are able to get that notebook open. We got the right link out. And yeah, we'll be following up with a recording of this so you can follow along at your own pace, using your free trial if you'd like, so you can kind of, get this use case going on your own. So we have time for a Q&A, so please feel free to keep putting your questions into the chat here. Let's see, here's a great one. So from Asim, do the advantages of Predibase only come in play with fine-tuning, or does it make sense to explore Predibase for serving open source models without fine-tuning to start with? Great question. I'm either Alex or Magdi. Do either of you want to jump in on that? Magdi, go for it.
Yeah, happy to take this one. I would say that yes, absolutely, it makes a lot of sense to use Predibase for serving open source models for two reasons. Number one, you get the advantages of the infrastructure that we built at Predibase, and that comes in two ways. Number one, you can choose to use a shared LLM. So that means that for you, the cost is going to be substantially lower and you can pay a per token price. Or we give you maximal sort of configurability to say, actually, I want to host it using the Predibase platform that has an abundance of GPUs available. So you can say, I want to set up my own dedicated version of like Llama 2 70 billion, for example, on the Predibase cloud. And so we make sure that there's the uptime and the availability that you want for something like a commercial grade LLM application using an open source model. And then the nice thing is you can fine tune ahead over that quite easily. So you don't have to choose either serve an open source model or serve a fine tuned model. You can have your open source model served, and then you can, with an adapter based approach, just try out fine tuning that you get for free, basically, if you have a dedicated LLM setup.
Great, thank you, Magdi. Another question from Andrew. How do you know when you should fine tune for a support application like this versus using RAG or use both? And I will say that we have another wonderful webinar from late last year on our YouTube channel about kind of the pros and cons of fine tuning versus RAG. So definitely check that out. But also I want to see if Magdi or Alex want to speak to kind of this use case and maybe a couple top of mind pros and cons of RAG versus fine tuning.
Yeah, happy to take this one. So it's so RAG is approach. RAG is an engineering approach. They are not in conflict. You want to achieve a result. You can try fine tuning and see how far it gets you. You would also want to investigate the RAG solution with a high quality knowledge base and make sure that your similarity search is adequate and fast enough so that you'll see if you need to complement your fine-tuning prompt with retrieved information, you can do it. And then you tune it. So one cannot answer this in absolute. One has to really, there's no way around experimentation and trying. But in general, these are complementary approaches. There are lots of guides for best practices on the internet. And we expect more. If you look at our predictions on our website, we expect more of this to be solidified for practice this year.
Thank you, Alex. Appreciate that. Let's see, just pulling another one out from the Q&A. Let's see, how does the output have fixed number of tokens? Was it the data or in the fine tuning where you have to specify the max sequence length or something like that? Is that one that one of you two can speak to? Talking about kind of fixed numbers of tokens and max sequence lengths?
So there are two things going on here. On one, to control costs, you want to budget for max sequence, just some reasonable number, so that if there are some exceptions in the output, they don't overblow the budget. And that's usually easy to set up. What is really happening that is pointing it is that this is the beauty of the fine-tuning approach. Your small example custom data set shows the input to output relations. And if the outputs are generally going to be small in number of tokens, like in our case, in our example for customer support, the task type, very brief, then that's what it will be trained on, and that's what it will stick to.
Great, thank you. Wondering if either of you could talk a little bit about data privacy. I've seen that question come up a couple of times. Do you want to talk about maybe how Predibase has different options for protecting data and ensuring privacy, especially compared to commercial LLM frameworks?
Yeah, I'm happy to take this one. So I would say there are a few very important things to consider here when talking about data privacy. First one is like data during training and data during serving. So if you want to fine tune on proprietary data, on a proprietary data set, we allow you to do that with full data privacy by using our VPC option for an enterprise account. And what that means is you come to us, you sign up to a Predibase account, but instead of running all our data-facing compute in our environment, we set up a cluster in your hyperscaler, in your cloud, whether that be Azure, GCP, or AWS. And so that's where your data lives. That's where all the compute lives. And we have very minimal communication between our servers and your data hosted stuff. So what that does is that it allows you to have full control of where the data is stored, but also the parts of our compute that actually process the data. And so let's say you've gone ahead and used the VPC option to fine-tune an LLM. The next thing you can do is say, hey, I want to serve that LLM. You can either set up a dedicated deployment in your own VPC, but at that point you are paying the cost of the compute. The other thing you can do is that you can then export that model and say, actually, I don't care about the model artifact that much because it's already gone through the data privacy. Like it's already like the model artifact is fine to expose on Predibase cloud, and then you can come to us and say, hey, can you set up a dedicated deployment, and then can I like hot load the LoRa that I fine-tuned over there? So you can share the model export between both versions if that's the case. But with the VPC option, you can get full data control and the data guarantees that you need to run a secure application.
Great, thanks, Magdi. Question just came in related to kind of a compare and contrast of Ludwig versus Predibase. We have a question saying that they had used Ludwig to fine-tune with Mistral 7B for the same use case, and want to know how it was different from using Predibase.
Well, that's an excellent question. You certainly can use Ludwig, and you just have to set up your own infrastructure with sufficient resources for GPUs. And if you're going to serve these models, you need to measure the time that it takes for each prediction to make and decide whether you're doing batch or online services. So you need to set up and then you have to operate it reliably with an uptime. That all are pretty daunting. This is what you want to do, and you have the budget and the staff for it. Predibase runs on Ludwig. So Predibase uses the latest version of Ludwig to perform machine learning tasks. But around this, Predibase has this enormous infra for hosting and serving at scale, including innovations that we talked about, serving adapters like 100 per one GPU to make it cost effective for our customers. So that comes from the team spending years at companies like Google and Uber and Amazon Web Services building infra. And so that's kind of what we offer. And indeed, Ludwig runs inside, and It's all part of Ludwig, and Lorax are powering Predibase.
Thank you, Alex. Here's a great question. How do we select, various models for a specific use case? What does that process look like? Figuring out which base model is maybe most applicable for your task.
So this is a great question, which is exactly where you do this initial proof of concept work. There is no way around. You can read all sorts of model cards. You can read all sorts of write-ups and announcements and blog posts, but ultimately, and read theory as well, because all of this stuff is rooted in deep theory. But ultimately, one has to make the code to work, and the code does not lie. So you're going to have to put together, hack up a notebook, an example, or set up a small lab with GPUs. There are several models. It's okay to do a selection. It doesn't have to take long, but a couple of weeks for tinkering and experimentation. You will find the model that works well for your needs, for your data sets, and your budget. And I would want to add is please come to the Predibase, look at our blog. There's wealth of information with examples on how to go about making these selections.
Thank you, Alex. We have another Ludwig question that might be good for you. Can we use the Ludwig classification head for the classification task for better performance?
So maybe we can talk more detail about this question in the Ludwig Slack, because and I would love to dive into it deeper. At a high level, you can save the model in Ludwig into local or Hugging Face environments, and then you can prompt this model from elsewhere. But in terms of classification head, well, it depends on what is done there. Is it a classic machine learning model, or is it large language model? So where does the classification head come in? What is the problem statement? Let's discuss it and find out what your use case is and what's the best way to solve it.
Thank you, Alex. We still have time for more questions if folks want to put anything else in the chat. Sorry if I missed anything further up. There was a flurry of activity. I think I tried to get to all of them, though. If you have any more questions, please do feel free to put them in. And great. Is there a community group for Ludwig, Slack or something? There is. Yeah, there's a Ludwig Slack community that you're welcome to join. Alex is very active in there and is a wonderful resource along with the rest of the community for that open source project. All right, here's one. Does Predibase have performance monitoring like traditional ML platforms like SageMaker? Do one of you want to speak toward that?
We are working on adding a lot more performance metrics for the serving side. But if you want to understand sort of training breakdowns, Predibase does provide a very comprehensive overview of the compute used and time taken and sort of where time is spent on each part of the training process. On the serving side, we are building out sort of a latency dashboard so people are aware of how long it's taking to get predictions and sort of the expected response time.
Thank you, Magdi. Wonderful. Well, thank you. Here we are. Question about suggesting any speech-to-text services. That might be a little out of our immediate scope, but if anyone has any thoughts either from the call or any other people in the chat, if you have any favorites, feel free to share.
Yes, so please contact us. I'm in Ludwig Slack all the time, or send us an email, and I will give you a recommendation.
Also, one quick shout out is that the company that provided the data set, GridSpace, have speech to text services, so check them out.
Okay, we'll do two or three last questions. One is about what if the fine-tuned corpus vocab is the same as the base model's vocab? I'm curious, first off, if that is, a common scenario ever. Yeah, maybe one of you want to speak to that.
So the question is if the corpus of what was used to pre-train the base model is it the same as fine-tuned data set. So let's start by saying that there are two things going on. Yes, the corpus for the pre-training is enormous. Now, the fine-tuned data set, number one, it doesn't need to be nearly as big. We talked about 1,000 to 10,000 exemplars. So that's one thing. Number two, the general pre-training corpus is usually not super high quality. Fine-tuned custom domain-specific data set must be high quality, and there are papers that actually do experiments and explain why that is. So it intuitively makes sense, garbage in, garbage out. So you want fine-tuned data set to be super high quality. But then there's one more subtlety, and that is you certainly want there to be no overlap, even if somehow the pre-trained data set was available and you would extract your fine-tuning data set from it. You would want to make sure that your fine-tuning data set has no overlap with what was used for pre-training, because otherwise it's data leakage in the sense that you're basically cheating the model. Too much hints, and then will exhibit in testing excellent performance, but in production it will not be so good. So one has to be very careful not to conflict these data sets. That's actually the most important part.
Great point, Alex. One more question about data privacy. So there's the consideration of data that you're using during the trainer and then the data during serving. So for data during serving, if you're using proprietary data during that serving part of things, is that data still walled off and not infused into the open source LLM? Let me know if either of you can speak to that or if you need any clarification on it.
Could you repeat the question?
Yeah. So for data during the serving, if you're, for proprietary data during serving, is that data still kind of walled off or protected in the same way? The question specifically was whether it's not infused into the open source LLM.
Yeah, I can give a quick overview. We don't store the input data at all unless it's given to us as part of a data set for fine tuning. So if you prompt a model with an adapter, some proprietary data, or just prompt an open source model with your own data, that doesn't stick around, and we end up restarting those models quite frequently. So even any traces of the logs or whatever will be gone in a few minutes. So that is in terms of data persistence. It's not infused into the base model. It's not stored anywhere. And then you control any fine-tuning runs that you want to do. You can choose which sort of data environment you want to use. And there you can choose whether or not the data set is stored on our cloud or on your cloud. But that is very much when you have decided to explicitly share data with us. Nothing is sort of stored without being very explicit about it.
Great, thanks, Magdi. How about, can you train multiple adapter layers and employ each layer in separate inference?
Yes. Let's say you have, assuming you are asking something like, can I train 3 or 4 different fine-tuned models and then use them all against the same base model, 3 or 4 fine-tuned adapters. Yes, we support up to many adapters at the same time. Basically, what happens is you send a request to the model with the link to the adapter. The adapter gets loaded onto the model, and we support having multiple adapters loaded onto the same model at the same time. So you don't even spend time reloading in the adapter. And so you can have something up to like, I don't remember the exact number, but definitely in the tens of adapters on the GPU memory at the same time. And so as you're having a lot of requests coming in, it acts as if it's part of the model. So you can have 5 up or 10 or many sort of fine-tuned models living at the same time, and you are just requesting, again, getting responses from these fine-tuned models on a single GPU.
Let's see, great. Oh, here's a really interesting kind of follow-up question to that. So that idea of having hundreds of adapters that can be hosted in the same GPU, for most real-world applications, do you think this is necessary? Only asking as, they might wonder if they're doing something wrong or underutilizing their resources. So like, I'm curious if you could maybe just elaborate on, some of those real-world applications of serving, dozens or hundreds of adapters on that single base model and single GPU.
Yes, I'd say there are two perspectives that one can take on this of why this is very useful. The first one is if you are someone who is trying to do a lot of personalization, like let's say you're an app that wants to personalize things per user, and you have multiple users, then you can very quickly see why you want to train an adapter per user, and then serve those all like multiplex at the same time. Then that becomes like, yes, it's a more enterprise application, but it allows you to do a level of customization, personalization for your users that is like just unfeasible without something like Lorax. And then the second perspective is sort of the cost savings. If you come to us and you say, hey, I want to use the shared LLM with my own fine-tuned models, something like Lorax allows us to pass on those savings to you by saying, like, we don't have to set up an entirely separate model for you. We can have that work across many of our customers simultaneously. So it helps Predibase users save on cost, and it helps sort of customers who do want to take that extra level of customization to do it over hundreds and hundreds of adapters in a way that I don't think was possible before.
Yeah, thanks, Magdi. And we're seeing more and more kind of customers and folks in the industry, especially as their organizations are growing, being able to find new use cases both internally and externally for additional fine-tuned models. So again, where historically they might have had kind of a financial blocker of, each additional fine-tuned model was a new deployment, and that cost, ramped really linearly. By taking that bottleneck or that cost restraint out of the equation, we've seen teams start to, iterate more on or innovate more on kind of where they start to deploy LLMs and their AI models. So we see huge, economies of scale and efficiencies from using that kind of framework, and have been really excited to see kind of how some of our customers and other people in the community are taking advantage of it. So thank you so much, everyone, for joining. We have, run out of time, unfortunately. But yeah, if you have any questions that we weren't able to get to on the call, please send an email to support@predibase.com, and we'll do our best to get back to you as soon as possible. And again, the recording of this will be sent out in the next couple of days. Really appreciate all the questions and discussion, and for taking time out of your day to join us. All right. Take care, everyone. We'll see you at the next one.
Thank you all.